Hello everyone, December the 7th. Alright, we're getting closer and closer to our goal. And it's getting closer and closer also to make a decision of what to do after we hit the goal. Yeah, we are about 27 days left, 17 days left, right? I think we calculated it's about end of the year we'll hit 2000 and then we'll call it. I probably won't continue to do this. I'll still, do it once in a while, but definitely not in any serious capacity. I think I've had enough of this. Maybe I'll check the hint, right? I'll check the hints first and then decide. Okay, that's what we're gonna do. So it's an easy question today, so should be enough time. We have ABC. Is a triple where this is the Pythagorean. Oh, what's that? I don't know the English for the Pythagorean. Pythagorean theorem. Okay, it's Pythagorean theorem. Give integer n, return the number of square triples such that it's this. So we need to find all the Pythagorean pairs, right? Well, we have the first two is going to be small and the last one is going to be big, and the first two will always can swap. So what you're going to do is first, second, and the third. Just try all of them. And then whenever you find one, you will double it because you can always double it. Alright, so we say rest is 0 for int a equal to 1, right? A is smaller than or smaller or equal to, but it cannot be n. For int b equal to a plus 1. Alright, c can equal to n. If a times a plus b times b equal to c times c, then rest plus equal to 2. And then we'll return rest at the end. I wasn't even thinking too much. I think we'll actually try, because the largest is 250. As long as it doesn't time out, I think we should be good. Should be good to go. Yeah, I think it's good to go. I wonder, maybe there's a mathematical way to do this. Yeah, pretty much there's a mathematical way to do this. We probably can terminate early or something like that, right? For example, if c smaller than this, can say, and also c need to be larger or equal to, because if c is smaller already, maybe I don't need to go through c, right? Yeah. We don't need to go through C. I have A and B, right? What we can do is A. Okay, and then we have C. Hold on. That's like solution 1. I have another idea. Okay, so 2 pointers ish. All right, we have hold on, let me just delete all of this. We can say A is 1, C is n. Okay, while A is smaller than C. Okay, then it's actually, no, that's not what we want. We want for A and for C, right? So A gonna go from 1 to the end. C is gonna be from, every time gonna be from this to the end. And as we go, we'll check if, you know, it's how do we check if it's a whole number? How do we check if it's a whole number? That is a good question. How do we check? I think we have this QRT. Right? I think we have this QRT. So like check for the existence of C. So no, still no. So for int A, 1, A smaller than n, that's fine, A++. For int B, A plus 1, B smaller than n, you know, B++, right? Int maybe C. C squared, right? C2, A times A plus B times B. If C2 is larger than n times n, well, break, because it's just too big. Otherwise, if, I don't know, do we have this QRT? Yes, we do. C2, right, and then we'll static cast this into an int, okay? So say int C will equal to this, right? If C times C is equal to C2, then rest plus equal to 2. Then we continue. And at the end we return. Okay, so this is slightly different. And let's see if this one works. And mainly if it's getting us faster. Okay? It should be faster. Yeah, it's much faster. This is much faster. This is like, what, 38 milliseconds? Right? And then this is faster. This is 0 milliseconds. Alright, let's see if there's any, I don't know, mathematical way. It could be. So this is okay, that's fine. Yeah. Yep, that's basically this one, right? Alright, so we're done with this one. I want to go back to let's go back to this one. So it didn't work, right? We tried it yesterday. We tried going from right to left, didn't work, and I think I need a hint. So in one pass, maintain prefix and prefix diff, and recording a hash map, the earliest index where each state occurs. Okay, so this is very similar to what we have, but slightly different. So I have a prefix, I have this. Okay, I have this. And what I want is a diff, number of even minus number of odd, and then recording a hash map, the earliest index where each state occurs. So for a given prefix exclusive OR and the diff. But isn't what we want is the diff to be... Oh, hold a second. It's a prefix, right? So prefix, wait, hold on. What's the prefix diff? So the prefix diff is the number. If I have the I here, then the diff is going to be number of even in nums, right? Even in nums all the way to I minus number of odd in nums all the way to I. So number of evens minus number of odd. What does this help us? So I know the difference. Okay, I know the difference. So in this range, the difference is this. And if I need to have the same number of even and the same number of odd, that means the difference need to cancel each other, right? Need to cancel each other. So let's say I have, let's say diff I is equal to 2, right? So we have the number of even is 2 more, right, than number of odd. Now we have another diff j, okay, is equal to -2, which means number of even is 2 less than number of odd. So we have, so if it's 2 less than 2, actually that doesn't work. We need to have the same. Okay. So it's also 2 more. So basically this, I say this is j, and then this is I. So we say the number of even is 2 more than odd in this already, right? And then we say the number of even is 2 more than odd in this as well. That means the number of even and the number of odd is the same in this range. From j to I, we have the same number of even and odd. And if we have the prefix exclusive OR for here and the prefix exclusive OR for here, if they are the same, then the exclusive OR of this subarray is equal to 0. Then we satisfy the requirement. Okay, so this is the key, the diff. Oh man, I did not get there. So I have prefix exclusive OR. This part I get. I have prefix number of evens. Okay, I did not get the diff. I only get the number of evens. Yeah, then you have the first time this occurs, and the second time this occurs, you will just find a diff. Like if you get another one, okay, yeah. So this I'm gonna do. Okay. All right, let's do this. That's gonna be a solution 2 here. Right, this is the one. Let's reset this. Yeah, let's reset this. And do it again. So the solution 2. So this one, yeah, we read the hints. Okay, so after reading the hints, right? After reading the hints, we know that the key is to find a prefix diff array, right? The diff represents the number of evens, the difference, right? Represents the diff array, the prefix diff array represents the difference between, right? Difference between the number of even numbers, the number of even values, and the number of odd values, right? So it's a difference between the two. So thus, if prefix diff I is equal to prefix diff j, then the subarray nums I, if this and I is smaller than j is smaller than I, then the subarray nums, actually it should be j plus 1 all the way to I plus 1, right? Has the same number of even and odd. On top of that, we use prefix exclusive OR to ensure to find the subarray with the exclusive OR equals 0. Okay. The next key insight is that we create a map with key being prefix exclusive OR and prefix diff. Right? We record the first index where each key occurs. Then that can be used, right? Can be used to calculate the longest subarray for each key. Yep, that is the idea. So what we need to do is we need to get a map of a pair int. So we can say prefix exclusive OR diff map. Okay, and then we'll go through the whole thing, and we need a so we need a prefix even, prefix odd, prefix exclusive OR. Okay, int I 0, I small and nums are size, I plus plus. Okay, I'm gonna go through this. So pref even plus equal to nums I mod 2 is equal to 0. Pref odd plus equal to nums I mod 2. Right, and then yeah, that's fine. And then pref exclusive OR equal to exclusive OR equal to nums I. Maybe I can do it this way. Mod of 2 is equal to 0, then prefix even plus plus, else prefix odd plus plus. Okay, and then we have I didn't have map out yet. Okay, so we have this, and then we say auto key std pair key is equal to prefix exclusive OR and prefix even minus prefix odd. Okay, if prefix exclusive OR diff map that contains k, what do? We actually don't even need this. If it contains, then we can compute, right? We can compute. We can say res, I don't have res, int res equal to 0, right? Then we say res shall equal to std maximum res, and so we need to go the length, right? So from the current I minus, so I have j is the previous one, so I minus j, right? Is 1, 2, 3, yeah, I minus j. J is going to be pref exclusive or map dot at key, right? Else pref exclusive or diff map key equal to I. And then at the end we'll return res. Wow, it's so much simpler. Can't even explain. Yeah, I'm gonna lose it. I didn't realize that it is that straightforward. The diff, yeah, the diff is the same. That means we have the same. So we're right for most of them. I think what goes wrong is we need a extra at the front. That's what we need. We need extra at the front. How do we get extra at the front? So we shall have a 0. I know. We don't do this. So this will get it a pair. I'll get a pair inside, right? So we say pref exclusive or diff map. So exclusive already is 0 and already 0. So this shall equal to -1. That shall work. There you go. Finally. Wow, it's struggle. The struggle is real. The struggle is real, man. 762. Well, that's mainly because we're using map. If we can find a better way, because a map has this for a hash, so if you have another way to do the hash, definitely can make it better. But I kind of don't want to. Alright, so that's pretty darn hard. Wait, why you don't allow me to upload this one? Okay. Alright, that's it. That's it for today. We have 24. Yeah, we should end it. We need to do this. Yeah, this has other issues. Alright, I'll see you guys tomorrow. Adios.